So let us discuss our topic where we left yesterday, stopping potential. Stopping potential. So if I draw the diagram again, this is one plate. This is one more plate. And this is a discharge tube in which the plates are embedded. And these two plates are connected like this. This is a switch. Then we have an ammeter. In equivalent and bit coach. And this is a supply. AC supply, DC supply. As you can see, this plate is maintained at higher potential. And this plate is maintained at lower potential. And this is the plate that releases electrons upon receiving the light. So this, I can say this is plate 1 and this is plate 2. And electromagnetic radiation is incident on this plate like this from the outside. Now, if the frequency of this radiation reaches to a certain level, from then onwards, electrons will start coming out of metal 1, plate 1. So what do you mean by stopping potential? This potential can be varied. This potential can be varied, and stopping potential, the minimum potential applied across plates such that so that every electron ejected from plate 1 is stopped from reaching plate 2. The minimum potential applied across plates so that every electron ejected from plate 1 is stopped from reaching plate 2. In other words, what can I write? I want to replace this complete statement with a more simpler statement. Can I say that electron with maximum kinetic energy should be stopped from reaching the plate 2? Because that covers everything. If electron with maximum kinetic energy is stopped, then every other electron is stopped. So you can say that electron with maximum kinetic energy is stopped. Got it? Now, what is the current? Now, this stopping potential, let us denote it by V0. And this is V. The applied potential is V, stopping potential is V0. Now, this is the current. Now, in which direction does the current flow? It will flow in this direction. This is the current. Because electrons will flow in this direction, current will flow opposite to the direction of electron flow. It will be flowing in this direction. So, for V greater than or equal to V0, I is equal to how much, tell me? For V greater than or equal to V0. That is, if you are maintaining a potential greater than or equal to stopping potential, then current in the circuit is how much? I'm waiting for your replies. I'm waiting for your reply. Yes, 0. Correct. Because statement chudandaya, the minimum potential applied across the plate so that every electron ejected from plate 1 is stopped. And every electron that is coming out of plate 1 is not reaching plate 2. When this electron is not reaching plate 2, where is the current coming? First of all, it should be 0. So I is equal to 0 if the potential applied across the plates is greater than stopping potential, and you need to know the polarity also. This plate 1 is maintained at higher potential, plate 2 is maintained at lower potential. Yeah, Karthik, assume that this potential is adjusted so that it is greater than stopping potential. Then adhamenti, electrons that are coming from plate 1 cannot reach plate 2. When electrons cannot reach plate 2, there is no flow of electrons in the circuit. When there is no flow of electrons in the circuit, current is 0. That is the meaning of I equal to 0. But if this polarity is changed, it is like this, assume. There is no concept of stopping potential that time, because this potential is aiding the flow of electrons. This potential is supporting the flow of electrons. So before solving questions on stopping potential, you need to see the polarity of this external supply. This polarity should be in this way. This ejecting plate should have higher potential, receiving plate should have lower potential. Have you all understood what I told? Yeah, Karthik is asking what is the cause for the electrons not reaching plate 2? Because this is maintained at higher potential, this maintained at lower potential. So what is established in between? Electric field is established. Direction of electric field is like this. This is direction of electric field. Now, when electrons are coming out of plate 1, this electric field will oppose the flow of electrons. This electric field will stop or slow down the flow of electrons. So at some point, the electrons will not go further forward. That time you can say that this electric field has stopped those electrons from reaching the other plate. Yesterday we have seen in this simulation all this. Is everyone following with me? Okay, good. Next. So how do you calculate this stopping potential? Once repeat. Okay. See, remember this polarity. This plate should be positive, should be connected to positive terminal. This plate should be connected to negative terminal. Then if you keep on increasing this voltage, it will reach a certain value, which is called V0. At that voltage, the electrons that are emitted from this positive plate will not reach negative plate. That minimum potential is called stopping potential. So if this external potential is greater than or equal to stopping potential, then current is equal to 0 because electrons are not reaching the other side. Let's see calculation. We have to consider what kind of electrons? Electrons with maximum kinetic energy. Because if we are finding out stopping potential for these electrons, then every other electron comes into picture. So you can say for an electron with maximum kinetic energy, for an electron with maximum kinetic energy, apply work energy theorem. Work energy theorem. What does work energy theorem state? Work done by all the forces is equal to change in kinetic energy. So work done by all the forces, internal forces, external forces, all kinds of forces is equal to change in kinetic energy. Right? What is change in kinetic energy? Finally, this electron is getting stopped. So final kinetic energy is equal to 0 and initial kinetic energy is equal to Ke max, because we are considering electron with maximum kinetic energy. And what is work done? Work is done by this electric field. Work is done by this external supply. What is work done on a charge? That is, I can write here separately. Work done on a charge is equal to Q into delta V. Have you seen this in electrostatics? Yes. Work done by what? This is not a complete statement. Work done by external force on a charge. That is equal to Q times delta V. So I want to find out the work done by electric field here. So what is the charge here? Electron. And what is the change in potential? That is, I'll reconstruct this statement. I'll write it like this. Work done by electrostatic force. This is equal to initial potential energy minus final potential energy. If I remember properly. Initial potential energy minus final potential energy. Work done by external forces, final potential energy minus initial potential energy. Here we are talking about electrostatic force. What is potential energy? Directly Q into initial potential minus Q into final potential. So I can write Q into Vi minus Vf. This is for work done by electrostatic force. Or you can write work done by an electric field. So let us put that here. What is charge? Charge is minus Q kada. That is why I'll write minus E. Charge is minus E. Negative charge is minus E into initial potential minus final potential. Just a second. This initial potential minus final potential. Obviously, this is at greater potential difference and this is at lesser this is at greater potential and this is at smaller potential. So I can say initial potential V1 minus final potential V2. So this I can write it as minus E into V gada. Minus E into V. But I am finding out stopping potential. So I can write E into V naught. This is equal to minus kinetic energy max. So this one plus. This implies what is V naught? Kinetic energy maximum divided by charge on an electron. What is kinetic energy maximum from yesterday's discussion? That is HF, which is nothing but frequency of the incident photon minus work function. Work function of the metal divided by E. Okay. This is V naught. Make a note. Now assume that you don't want to do this much analysis. Work done by electrostatic force, UI minus UF. ఇదంతా మీకు అసలు గుర్తులేదు, ఇష్టం లేదు. అప్పుడు ఎలా చేస్తారు? You assume that electron is here. Electron is here. So in which direction it is experiencing force? It is experiencing force in the backward direction. And in which direction is it moving? It is moving in forward direction. So work done is what? Work done is negative. Force is in negative direction. Displacement is in positive direction. Work done is negative. So how do you find out work done? Charge into potential difference. So this is charge, this is potential difference. Since work done is negative, you'll write minus EV. Same thing only, no? E minus EV ne ikkada rasam. But that got cancelled because of this potential energy, plus and plus. అర్థమైందా లేదా? Have you all understood this? Good. Make a note fast. I don't want you to see any book. Okay. Only keep your class notes open and solve this question. Okay, I'll solve this question after discussing saturation current concept. Solve this question once again. I mean, one more question. Leave some space for the previous question. These are two plates as usual, and this is the discharge tube. And this is ammeter. And this time, the potential, I mean the polarity is in this way. You can see here. This is maintained at lower potential and this plate is maintained at higher potential. Got it? And this is the light that is being incident on the plate. This is the plate that is causing the ejection of electrons, or you can say this is photosensitive plate. So obviously the electrons will move from this plate to this plate. So current will be in this direction. Current will be in this direction. Now I want you to plot some graphs. Plot a graph between option A, photocurrent. What is photocurrent? The current that is flowing in the circuit. This is photocurrent. Plot a graph between photocurrent and applied voltage. At a constant frequency of incident light but for two different intensities. You need to plot a graph between photocurrent and applied voltage at constant frequency of incident light, but at two different frequencies. You can say I1, which is greater than I2. There are two different intensities of light. Next, I need to plot a graph between photocurrent and applied voltage. Photocurrent and applied voltage at constant intensity. At constant intensity of light, but at two different frequencies. Two different frequencies, and you can take F1, which is greater than F2. What frequencies? two different frequencies of incident light. The first part I will do, second part you try by yourself. Okay. And we are talking about steady state when everything is properly established. We are not discussing about transient state. Applied voltage is V. Okay, this is the applied voltage. This is positive terminal and this is negative terminal. So this plate is maintained at higher potential. This plate is maintained at lower potential. So electrons are emitted like this. Electrons are emitted. And what is the direction of electric field? This is positive plate and this is negative plate. So electric field direction is like this. And electrons direction is like this. So electric field is supporting. Okay, electric field is supporting the flow of electrons. So there is nothing called as stopping potential concept here. So we can plot a graph between what and what? Between photocurrent I. This is I. Between photocurrent I and potential V. So tell me how does it look if you increase the potential? If you increase the potential, will the I increase? If you increase the potential, will the current increase? Directions are opposite to each other. How is it supporting? Once can you explain? Array, this electron is negatively charged, kada? If this electron is, if this is a positive charge, then it will have tendency to move in the direction of electric field. But this electron is negatively charged, so it will have natural tendency to flow in the direction of opposite of electric field. So electric field is in this direction and the electron will flow in this direction. So this electric field is not opposing the flow of electron in any way. No? First of all, tell me, if potential equal to 0, will the current be equal to 0? Tell me that. Potential is equal to 0, then current is also equal to 0. No, that is not possible. So I'll plot graph something. I'll plot graph in red line. So I can say that current is already there when potential equal to 0. So this is the current. Now, as you keep increasing the potential, the current also will slightly increase and it will reach a saturation value. So it is something like this. Like this. This is saturation. I'll draw it more properly. Like this. So this is saturation value of the current, I sat. That is, if you further increase the voltage, current will not increase. Current has reached its maximum. Got it? Now, if you want to produce this line back, what do you mean by producing this line back? That means potential is becoming negative and the polarity is reversed. And this is positively charged and this is negatively charged. That time, if you produce this line back, at some voltage, current will be 0. If you produce this line back like this, at this particular voltage, current will be 0. I can call it as minus V0. What is this voltage called? Tell me. What is this voltage called? Stopping potential. అదేంటి అసలు ఈ కనెక్షన్ లో స్టాపింగ్ పొటెన్షియల్ కాన్సెప్టే రాదు కదా అని మీకు డౌట్ రావచ్చు. ఐఎమ్ చేంజింగ్ ది పొలారిటీ కదా. సి ఫ్రమ్ ఇఫ్ యు ఆర్ మూవింగ్ towards the negative x-axis, polarity of V is changed. That time this will become positive and this will become negative. So this is higher potential plate, this is lower potential plate. And if you keep on increasing the magnitude of V, somewhere it will reach stopping potential. At stopping potential, current is equal to 0. And on what factors does the stopping potential depend? You see here from previous slide. Stopping potential is equal to this much, HF minus phi divided by E. So I can write V naught is equal to HF minus phi divided by E. So stopping potential depends on the frequency of the incident light. Stopping potential depends on the work function of the metal and charge of an electron. It does not depend on intensity. Stopping potential does not depend on intensity. So you're plotting graph for two different intensities. So these two different intensities should have same stopping potential or not? Are you people following the class? Yes. So how will you draw the graph? You have to draw a graph in this way. Now, which is I1 and I2? Which is I1 out of these two lines? Top line or bottom line? Top line, obviously. Higher intensity and enti, more number of photons are falling on this plate and more number of electrons are coming out of the plate. So more current. So more will be saturation current. So this is I1 and this is I2, where intensity of I1 is greater than I2 and frequency is constant. Frequency is constant. That is why the stopping potential is also same for both the intensities. So this is for A bit. Did you understand this question? Now try to answer second bit, B bit, all of you. Try to draw the graph. I'll come back. If I call this as plate 1 and if I call this as plate 2, so what will I write for V? V is equal to second plate minus first plate. Because V, the positive terminal is connected to the second plate and negative terminal is connected to the first plate. So what is this V? Potential of this positive plate. Positive plate is called anode and negative plate is called cathode. So potential of anode minus potential of cathode. So let me draw the same graph for B bit. B bit, I want to draw the graph. Yes, this is photocurrent I and this is applied voltage V. Now you want to plot photocurrent versus applied voltage at constant intensity of light, but at two different frequencies. Two different frequencies and two stopping potentials will be there. Agree or not? Because look at stopping potential expression. V naught is equal to HF minus phi divided by E. Here metal is same, so phi is same. But F is different. Two different frequencies, kada? So two stopping potentials. So I can have two stopping potentials here. One is here and another is here. I can call them as VO1 and this is VO2. Got it? And how does the graph look? You can draw the graph like this. Again, same. Something like this. Where this is the saturation current. Now, final saturation current, does it depend on frequency? Ninna kuda manam experiment lo chusam. The final saturation, the current is not depending on frequency. Frequency will decide whether electrons to come out or not. Once electrons have come out, okay, current depends on intensity. It does not depend on frequency. Frequency will tell you how fast are the electrons moving. Frequency will tell you how fast are the electrons moving. So you can say that graph ఎలా ఉంటుంది ఇలా ఉంటుంది ఈ రెండు కంబైన్ అయిపోతాయి. Something like this. Okay, so because intensities are same, constant intensity. Now which is F1, which is F2? Tell me, out of these two, this left side is F1 or right side is F1? Left side is F1, this is F1, and this is F2. Because F1 is greater than F2, obviously stopping potential corresponding to F1 will be greater than stopping potential corresponding to F2. Of course, I need to have negative sign here. Okay, if you see with negative sign, then VO1 is less. But if you see only magnitude, VO1 is greater than VO2 in magnitude, because F1 is greater than F2, and this is constant intensity. Constant intensity. And what can I write here? Constant frequency. Now you may get one question. What is that? Does the current depend on this voltage? Because current depends on number of electrons that are coming out of the plate. That depends on the frequency. That depends on intensity and frequency. But frequency will decide whether electron to come out or not. Once electron is starting to come out of the plate, intensity will decide how many electrons to come out. So intensity will decide the current. But as you can see, this current also is depending on the external voltage. How? You can, if you look at this graph, this part from here to here is very, very, very steep. Steep ante enti? Something like this. Graph asalu ideal ga chuste graph ila untundi. Ante from here to here, the current is instantly increasing, and thereby it is constant. Okay, it is suddenly increasing, and after that it is becoming constant. And from here to here, it is increasing with increasing voltage. How can you attribute? Due to some voltage also, you can assume that some charges are coming out easily, because voltage also will try to support the ejection of charges. Okay, high voltage is placed between the charges, between the plates, then that voltage also will play a very small role in ejection of the charges. So remember that from this point to this point, the graph is very sudden, it is very steep, and this part occupies most of the graph. I want to plot this graph more accurately. It will look something like this. IV, this is stopping potential. Okay, so at stopping potential, current is equal to 0. And if the potential is less than stopping potential, I mean, that time current will be there. So it will be like and suddenly it is like 0, 1 state. This is 0 state and this is 1 state. The slope that will be almost a vertical line. I have drawn it like this. Why I drew, I don't know, but the graph will look like this. In exams, if you find graphs like this, understand, I mean, these are also correct only, but understand that the steepness of this sudden change 0 to 1 is very, I mean, this change 0 to 1 is very steep. Okay, for very less amount of voltage, current will suddenly rise, and thereafter current will keep constant. Yeah. So here, where the current becomes constant, what do you mean? All the electrons that are emitted are being collected by this plate. And what is in this level? All the electrons that are being emitted are not collected at this plate. Some electrons are not having sufficient energy to reach to this plate. Some electrons are having sufficient energy to reach to this plate. That is why current is slowly increasing with potential. Let me understand let me clear that small doubt. Miremankuntunaru, see, if you increase the potential, how will the number of electrons ejected from this plate 1 increase? Ade kada mi doubt. Because number of electrons that are being ejected depends on intensity. So if intensity is constant, number of electrons that are coming out of the plate also should be constant. Then for a constant intensity curve, if you increase the voltage, how is the current increasing? For that, explanation is that all the electrons that are coming out of this plate 1 may not reach plate 2 because different electrons will have different energies. Some with more kinetic energy will reach the plate 2, some with less kinetic energy will stay there only. Somewhere they will be moving around like this. So if you increase the potential, you are giving more energy to those electrons with less kinetic energy. So those electrons can reach the plate 2. Like that, keep on increasing the voltage. There will be a certain voltage where all the electrons that are ejected here are reaching here. Further, if you increase the voltage, there is no impact on the electrons because all the electrons here are reaching here. That is when current becomes saturated. Did you understand, all of you? When a monochromatic point source of light. What do you mean by monochromatic? Single wavelength or single frequency. That is monochromatic, okay? Point source of light is at a distance of 0.2 meter from the photoelectric cell. The cutoff voltage and the saturation current are respectively 0.6 volts and 18 milliamperes. What is saturation current? What is cutoff voltage? Cutoff voltage and is a stopping potential. Same thing. If the same source is placed at 0.6 meters away from the photoelectric cell, then what happens to the stopping potential? What happens to the saturation current? Sorry. Stopping potential enti? What is the formula? V naught is equal to HF minus phi divided by E. This is the formula for stopping potential. Now, this is the plate and this is the point source. Now, this point source is emitting light like this. Okay. Now, this point source is shifted. Initially, it was closer to the source and it got shifted. Initially, this distance is 0.2. It got shifted like this. Now, this is the point source. Initially, point source was here. This is position 1. And after some time, it got to position 2. You are shifting the point source and you are not changing the frequency. You are also not changing the work function because work function depends on this metal. This is having a fixed work function. So by changing the source, you are not changing frequency or not changing work function until you are not changing stopping potential. So stopping potential will remain same, option B. So out of A and B, it is option B. Now look at C and D. Saturation current. Look here. Look at the graph that we have drawn. Saturation current. Here I1 and I2 are the saturation current. Sorry. ISAT1 and we can say ISAT2. are saturation currents corresponding to these two intensities, I1 and I2. So saturation current depends on the intensity. Obviously, from common sense also you can guess that, because intensity will tell you how many photons are incident per second per area. I'm sorry. Yeah, intensity will tell you how many photons are being incident per second. So when you are moving away, intensity is increasing or decreasing? Tell me. Intensity is decreasing. So number of photons incident on this plate per second is also decreasing. So current should decrease. Saturation current should decrease. Ante directly it is ikkada rendu undachu, because initial saturation current is 18. Here it is 6 and 2 milliampere. It can be both. Now qualitatively you have decided that it could be C or D. Now let us quantitatively derive. Intensity, he has said point source. In wave motion and sound chapter, we discussed about intensity of point source. Intensity is proportional to 1 by r square, where r is the distance from point source. How do you get this expression? Can you tell me? How do you get this expression? First of all, what is energy? Power by area, and assume that this is the point source emitting constant power in all directions. Now, if you take this point P, then form a sphere like this. Form a sphere. So how do you find out intensity at point P? Intensity is equal to power, which is point P badlu point A bedtam. Okay, and this is power. So power by area. What is the surface area of this sphere? 4 pi r square. So intensity is inversely proportional to r square. From that you got this. Since it is a point source, intensity is inversely proportional to r square. So and I already know that current is proportional to intensity. Saturation current is proportional to intensity, and intensity is proportional to 1 by r square. This is very important. Saturation current is directly proportional to intensity, because intensity will decide number of photons incident. Intensity will decide number of electrons that are coming out. So saturation current is directly proportional to intensity. Intensity is directly proportional to 1 by r square. This is one important relation that you need to keep in mind. So tell me, what is ISAT1 by ISAT2 in this case? ISAT1 by ISAT2, that is equal to R2 square by R1 square. So from here, ISAT1 is how much? Saturation current initially is 18 milliamperes divided by ISAT2, that is equal to, final distance is how much? 0.6 divided by initial distance is how much? 0.2 whole square. So from here I can get ISAT2. ISAT2 is how much? 18 into, this will become 1 by 18 into 1 by 3 square. So 18 into 1 by 9. So this is 2 milliampere. So it is option D. Now tell me, have you understood this question? This is IIT JEE 1992. Understood kada everyone? All this question. Select a graph that shows plot between K max and F, V0 and F correctly. For a given metal. I mean, the work function is fixed, and what is V0 here? V0 is stopping potential. V0 is stopping potential, and the metal is fixed. See here on y-axis, there is Kmax or V naught in the same scale, assume. And you put Kmax, you are plotting as 1.1 joule, 0.2 joule, 0.3 joule, 0.4 joule, like that. Then V naught, you should plot it as 0.1 volt, 0.2 volt, 0.3 volt, 0.4 volt, and so on. Hope you understand that. Okay. So first write the equations. Write the equations for Kmax and frequency. What is the equation? What is maximum kinetic energy? That is equal to HF minus work function. This is the equation. So Y is equal to, first of all, this can be compared with this equation. Y is equal to mx plus c, where this is the frequency, x is frequency, m is slope, and c is this work function. One more equation is what? This Kmax, this maximum kinetic energy in terms of stopping potential, how to write? How to write Kmax in terms of stopping potential? See here. Kmax can be written as E into V naught. Chusar kada? So write that here. Kmax. Kmax is equal to E into V naught. That is equal to HF minus phi. So V naught is equal to H by E into F minus phi. So this is one equation. This is one more equation. Now, how do you come to a conclusion about the result? You need to see the slope. You need pi by E, sorry. Should be pi by E, correct. You need to see the slope. One slope is H, another slope is H by E. Which slope is greater? Tell me. H slope or H by E na? What is E? Charge on electron. 1.6 into 10 to the power minus 19, which is less than 1. So H is greater. H is greater ante kinetic energy maximum. That should have greater slope compared to V naught. So which is kinetic energy maximum? This B is correct. Did I make any mistake? Just a second. Which should have greater slope? Tell me. E is less than 1. E is less than 1 ante H by E should have greater slope. H by E should have greater slope ante V naught should have greater slope. V naught is corresponding to graph 2. Graph 2 should have greater slope. Graph 1 should have less slope. Option A is correct. Did you understand this question?